A is a 2 by 2 matrix, B is a 2 by 3 matrix. Giving a reason for your answer, explain whether it's possible to evaluate A, B, and A plus B. So to be able to do a multiplication, you have to have that the second number here, which is the number of columns, is equal to the first number here, the number of rows. And it is, so we're okay. A, B, possible, since number of columns in A equals number of rows in B. Whereas BA would not be possible because there's 3 columns in B and only 2 rows in A. A plus B, the only way you can ever add matrices is if they're the same size, and they're not here. So not possible. Since A and B are different sizes or have different dimensions. We're now given this equation and asked to determine the value of lambda. So what we're going to do is multiply out the left-hand side. So we're going along this row and down this column. And I'm going to get minus 5 times 0 plus 3 times 2 plus 1 times minus 1. That's going to give me 5. And then I just move along the column. I'm hoping that you've done many it's awkward when you first do this, but you've done enough now to know, yeah, you just kind of cycle through a little system. Here I've got minus 25 plus 36 minus 11. We get 0. And basically just keep going. We get 0 for the next one. Then a 0 here. For the middle one, we actually get 5a. Then 0. Okay, then the last one is the most complicated. We get 2a minus b. Because I'm now going along this row and along the first column. So 0 times b plus 2a minus b. Then 12a minus 6b. And 3b minus a. And remember, this is equal to lambda I, which is actually lambda times the identity matrix. It looks like this. Sorry, I'm just squashing it in there, but that's okay. So if we now compare them, we can see that lambda is going to have to equal 5, because I can just compare these two. And then I can compare this and this. I know the lambda's 5, so that means A is going to have to equal 1. And then there's a few I can compare for B. I've got 2A minus B is equal to 0, so that means 2 minus B is equal to 0. B is going to have to equal 2. We can just double check with the others. So if I check this out, it would be 12 minus 12, that is 0. If I do 3b minus a, I'd get 6 minus 1, it's 5. So I can be really confident with those answers. Hence, deduce the inverse of this matrix here. So we know we've got two matrices multiplied together that give a multiple of the identity matrix. And what that means is if we divide through by lambda, I can have this multiplied by 1 over lambda times the second matrix, and that is going to equal I. And you know that if you times a matrix by another matrix and get the identity matrix, then they are inverses of one another. Therefore, our inverse is going to be 1 over 5 multiplied by 0, 5, 0, 2, 12, minus 1, minus 1, minus 11, 3. Just leave it like that. Okay, given this matrix, we're now asked to determine the values of theta for which the matrix is singular. So singular is when det m is equal to 0. Non-singular is then when it's not equal to 0. So let's work out the determinant. Now, this is one of those situations where choosing the row and the column will massively help or hinder you. Because there are 2 zeros down this column, it's going to be best to expand along the column. So the determinant m is going to equal 1, and then we find the determinant of sine theta, cos theta, cos 2 theta, and sine 2 theta. And that's it, because then we get minus 0 times some determinant plus 0 times some determinant. They're not gonna come into it. Whereas if you expand along this row, which is quite often what people do, then you're just gonna get these extra terms, and they're gonna become 0 as well, but it's just gonna require more effort. So by all means do it, but I would say try and spot the best row or column to expand by, because you can do any of them. You just got to remember to do minus 1 to the power of the row plus the column for whether you get your pluses or your minuses, or of course you could write down like plus, minus, plus, like this kind of pattern. Anyway, I'm not going to go into it anymore. Now we expand this determinant, we're going to get sine theta, sine 2 theta, minus cos theta, cos 2 theta. And we want to solve that equal to 0. Which looks quite an awkward trig equation until you recognize that actually we can use double angle formulae, because cos A plus B, you can look this up of course, it's cos A cos B minus sine A sine B. So we could either like rewrite it like that, or we could just bring a minus out if you wanted. It's not going to matter. So it will then become cos of 3 theta, because A is theta, B is 2 theta. I'm just adding them together. And now I can get rid of the negative. So that's what I want to solve. Now, theta is between 0 and pi, which means 3 theta is going to be between 0 and 3 pi. So we solve for 3 theta, inverse cos of 0. We're going to get pi over 2 as our first answer from our calculator. Second answer is then 2 pi minus pi over 2, so 3 pi over 2. That's still in the range. And our third answer is going to be if we just add 2 pi on, and it's going to give us our next one here. And that is 4 pi over 2 that we're adding on, so we're going to get 5 pi over 2. Which means that theta is going to be pi over 6, pi over 2, or 5 pi over 6. Those are our 3 values that will lead to a singular matrix. Well done.